All right, today we're going to dive into the world of indices. Now, I want you to think of them as these really powerful shortcuts in math that'll save you a ton of time and effort once you know how they actually work, of course.
So what if? What if by the end of this, you had a brand new set of mathematical tools that felt kind of like learning a secret code? Well, that's exactly what we're about to do. Unlock the rules that make handling these numbers an absolute breeze.
But before we start building anything new, every project needs a solid blueprint. So first up, let's do a super quick refresher on the basics, just to make sure we're all on the same page.
Okay, so in any power, like 2 to the power of 3, there are two key parts. You've got the base, that's the main number, the one being multiplied, and then you have the index, that little number up top telling us how many times to multiply that base by itself. Simple as that.
So at the end of the day, index notation is just a really neat way to write down repeated multiplication. I mean, instead of writing out 2 times 2 times 2, we just write 2 to the power of 3. It's an efficient shorthand, and that's the core idea we're going to be building on.
All right, our foundation is set. Time for our first tool. Let's call this one the grouping tool. It's an awesome rule that helps us deal with powers when multiplication is happening inside parentheses.
Let's break this down visually. We're starting with 2 times 3 squared. Well, that just means we write 2 times 3 twice. And once you get rid of the parentheses, you've just got this simple string of numbers. See how we can just rearrange them to get all the 2's together and all the 3's together?
So here's that exact same process, step by step. First, we expand it. Then we rearrange. We group up the numbers that are the same. And finally, we convert back into that clean index notation. Are you seeing the pattern here? The power that was on the outside, it basically just got handed out to each number on the inside.
And here it is, the general rule. This is our first major tool for the toolbox. For any numbers a and b multiplied inside parentheses, and the whole thing is raised to the power of n, well, you just apply that power to each number individually. So ab to the n becomes a to the n times b to the n. A really powerful shortcut.
Now, here's the cool thing. Any powerful rule in math is kind of like a two-way street. We can use this exact same principle, but in reverse, not to expand, but to simplify. This is the other side of the coin. Let's call it the shrinking tool, for taking a longer expression and making it way more compact. Just take a look at this comparison. On the left, you've got 36x squared. On the right, 6x squared. Now, they might look different, but they are exactly the same thing, because 36 is just 6 squared, right? So you can see that 6 squared times x squared can be rewritten as 6x squared. And this is why it matters. Simplifying expressions like this is the key to solving much bigger problems down the line.
Here's the same rule, but just with variables. If you see two different things that have the same index, like a cubed times b cubed, you can just combine them under one set of parentheses. It's the grouping tool just running in reverse. This is incredibly useful for tidying up your math. Okay, so we've handled products. But what happens when we throw negative numbers into the mix? This is where our third tool, what I call the sign flipper, comes in. It's all about predicting what happens to the sign when your base is negative.
Check out the pattern in this table. For the positive number up top, the answer is always positive. No surprise there. But look at the negative numbers. For -1, the second power is +1, but the third power is -1. Same thing happens for -2 and -3. The sign just keeps flipping back and forth.
So take a second. When does the answer end up positive and when does it stay negative? The clue isn't the base number itself, it's the index. Do you see the pattern? And here are the rules in all their glory. A negative number raised to an even power, like 2, 4, or 6, will always turn out positive. That's because the negative signs pair up and cancel each other out. But a negative number raised to an odd power, it's always going to stay negative. That's the sign flipper rule. So there you have it. In just a few minutes, you've literally added 3 powerful techniques to your math skills. Let's do a quick recap of these new superpowers we've just unlocked.
Here it is, your complete math toolbox. You've got the grouping tool and the shrinking tool, which are really just two sides of the same coin, to expand and simplify products. And you have the sign flipper rules to instantly know the sign of your answer when you're working with negative numbers.
And remember, these aren't just some abstract rules to memorize. They're real tools for solving problems way more elegantly.
They let you look at a complicated mess of an expression and see the simpler truth hidden right inside. So the real question is, what are you going to